Hey, welcome to The Explainer. Today we're going to tackle three words you probably hear all the time: work, energy, and power. But what do they really mean in physics? Well, it turns out they're all connected, and they basically explain how the entire universe runs. All right, let's just jump right in with a question. So picture this. You're on a roller coaster. After that first big, clanky climb to the top, how does it manage to do the rest? All those twists and turns and loops, all on its own. There's no engine, right? So what's the deal? What's the secret sauce here?
Well, the answer is it's running on this amazing, invisible currency, the currency of motion, and we call it energy. And that's exactly how I want you to think about it for the next few minutes. Just imagine energy is money in this giant economy of motion.
So that brings us to our first big idea here. Okay, so if energy is the money, then how do you actually earn it, or transfer it, or spend it? Well, the answer to that is a little concept we call work. So in physics, work is literally the transfer of energy. That's it. It is the transaction. It's the moment money changes hands. Think about it. When you lift a heavy box, you are literally doing work on it. You're taking energy from your own body and transferring it into that box. You're basically making a deposit right into its energy account. But, and this is a big but, there's a really important rule here. For work to actually happen, for that currency to change hands, something has to move. You could lean against a brick wall with all your might for hours. You'd get tired, right? But if that wall doesn't move an inch, guess what? In the world of physics, zero work has been done. No transaction took place. But the second you lift a box off the floor, bam, it moved. That's a successful transaction. Energy has been transferred. All right, so work is how we move the money around. But where does the money go? Like, what kind of accounts can we keep it in? Well, let's break down the two big ones. Think of it as your spending account versus your savings account. First up, we've got kinetic energy. This is the energy of doing stuff, the energy of motion. In our little economy analogy, kinetic energy is like the cash in your wallet. It's right there, ready to be spent. It's active. It's happening right now. And then, on the flip side, you've got potential energy. This is your savings account. It's stored value. The money's there, all right? It's just waiting to be transferred over to your spending account. So yeah, let's put these two head to head. You see a car speeding down the highway? That is pure cash-in-hand spending. That's all kinetic energy. But what about the water just sitting there behind a giant dam? That's your savings account, maxed out. Just a massive amount of potential energy, stored up and waiting for the right moment. Same deal with a rolling ball versus a stretched bow. One is all about action, the other is all about, well, potential. Cash versus savings. Okay, now every economy, real or imaginary, has to have rules, right? And this economy of motion has one single, absolutely unbreakable rule, and it governs everything. It's called the law of conservation of energy, and it's actually pretty simple. It just says you can't create energy out of thin air, and you can't make it disappear. Basically, the total amount of money in our entire universal economy is fixed. It's constant. All you can ever do is move it around. And boom, just like that, we're back to our roller coaster. So when that coaster is at the very, very top of the first big hill, it's moving super slow, right? So its cash account, its kinetic energy is almost empty. But because it's so high up, its savings account, its potential energy is absolutely overflowing. And as it starts to plunge down that hill, it makes a massive withdrawal from savings and puts it all into cash. Potential energy gets converted into kinetic energy, and the car goes faster and faster until right at the bottom of the hill, it's hit maximum speed. All cash. Okay, but hold on a second. We all know that roller coaster isn't going to go on forever. It slows down. It eventually stops. So if energy can't be destroyed, where the heck did it go? This is where we have to talk about hidden fees. See, the thing is, not all transactions are perfectly efficient. Some forces, like gravity, are what we call conservative. They're like a perfect fee-free bank transfer. But then you have forces like friction and air resistance. These guys are non-conservative. And you can think of them as, well, they're like a transaction fee or a tax. Every single time the wheels rub on that track, a tiny little bit of that precious motion energy gets skimmed off the top. It gets turned into heat or sound, and it just leaks out of the system. And those little fees, they add up, and that's what eventually grinds the ride to a halt.
Okay, so we've got our currency, energy. We've got our transactions, work. But there's one last piece to this whole puzzle, and that's speed. How fast do these transactions happen? And that, my friends, brings us to power.
Power is super simple, really. It's just the rate of the energy transfer. It's not about how much work you do, it's about how fast you do it. In our economy analogy, this is your cash flow. How fast is the money moving in and out of your accounts? Let's go back to lifting that box. The total amount of work, the total energy you transfer, is exactly the same whether you lift it in 2 seconds or 4 seconds. The box ends up in the same spot, right? But if you heave it up there in just 2 seconds, instead of taking a lazy 4 seconds, you've done the same work, but you did it twice as fast. You just used twice the power. Simple as that. All right, let's wrap this all up with a super quick review of our economy of motion. Work is the transaction. Potential energy is your savings account. Kinetic energy is your cash on hand. The law of conservation is the unbreakable rule that the total budget never, ever changes. Friction, that's the annoying transaction fee that bleeds energy away as heat. And power is your cash flow. It's just how fast all those transactions are happening.
And all of this leaves us with one final, really big question. If the total amount of energy in the entire universe is fixed, if it's all just been changing forms since the beginning of time, where did the universe's original budget come from? Who made the first deposit? Now that is something to chew on. Thanks for tuning in.